Introduction. Sumit and his mother are standing at the window and watching outside. The weather is looking good and there is a probability of first rain of the season. Suddenly, rain starts. Sumit requests his mother to let him go outside and enjoy the rain. But his mother didn't allow him to go outside in the rain. She said that the very first rain may be an acid rain, and an acid rain is harmful for us. Sumit didn't have any idea about that and asked her, "What is acid rain?" She replied him that atmosphere have many polluted particles like carbon, sulfur and nitrogen. These particles make redox reactions with water drops and turn them into acid rain. Students, redox reactions are all around us. Burning of fuel, digestion of food, decay of organic substances are few examples of redox reaction. Today, we will more discuss about the redox reactions. Objectives. At the end of this lesson, you will be able to define redox reactions, familiar about classical idea of redox reactions, understand electronic concept of oxidation and reduction reaction, know simultaneous occurrence of oxidation and reduction, calculate oxidation number, define oxidation and reduction in terms of oxidation number, understand types of redox reactions, do balancing by ion electron method and oxidation number method, analyze redox reaction and electrode process, define electrochemical cell. Definition. In our daily life, we come across processes like rusting of iron, fading of the color of the clothes, burning of the combustible substance such as cooking gas, wood, coal, etc. All such processes fall in the category of specific type of chemical reactions called reduction oxidation or redox reactions. Classical idea of redox reactions. Oxidation. It is a process of addition of oxygen or any electronegative radical or removal of hydrogen or any electropositive radical. Reduction. It is a process of addition of hydrogen or any electropositive radical or removal of oxygen or any electronegative radical. Let us take some examples for better understand the redox reaction. Reaction of PbO and carbon. Here, oxygen is being removed from lead oxide and is being added to carbon. Thus, PbO is reduced while C is oxidized. Reaction of H2S and Cl2. Here, hydrogen is being removed from hydrogen sulfide and is being added to chlorine. Thus, H2S is oxidized and Cl2 is reduced. Electronic concept of oxidation and reduction reaction. Electrochemical reactions occur as a result of transference of electrons from one species to the other. Consider an example. If magnesium is burnt in oxygen, it gets oxidized to magnesium oxide. In the formation of magnesium oxide, 2 electrons from magnesium atom are transferred to oxygen atom. Oxidation is a process in which an atom or a group of atoms taking part in chemical reaction lose one or more electrons. The loss of electrons result in the increase of positive charge or decrease of negative charge of the species. The species which undergo the loss of electrons during the reactions are called reducing agents. MnO4, 3 negative, Fe2 plus and CO are reducing agents in these examples. Reduction is a process in which an atom or a group of atoms taking part in chemical reaction gains one or more electrons. The gain of electrons results in the decrease of positive charge or increase of negative charge of the species. The species which undergo gain of electrons during the reactions are called oxidizing agents Ag+, Fe3+. FeCN6(3) negative are oxidizing agents in these examples. Simultaneous occurrence of oxidation and reduction. Since oxidation involves loss of electrons and reduction involves gain of electrons, it is evident that if one substance loses electrons, another substance at the same time must gain electrons. This means that in any process, oxidation can occur only if reduction is also taking place side by side and vice versa. During the redox reaction, there is transference of electrons from the reducing agent to the oxidizing agent. In this reaction, zinc atoms lose electrons and are oxidized to zinc ions, whereas cupric ions gains electrons and are reduced to copper atoms. Here, cupric ions act as oxidizing agent and zinc atoms act as reducing agent. Every redox reaction can be split up into two half reactions. One representing loss of electrons, known as oxidation half reaction. Other representing gain of electrons, known as reduction half reaction. The reaction can be split up into half reactions as SN2 positive gives rise to SN4 positive plus 2 electrons. This equation is oxidation half reaction. And 2Hg2 positive plus 2 electrons gives rise to Hg2 2 positive. This equation is reduction half. Oxidation number. Oxidation number of the element is defined as the residual charge which its atom has or appears to have when all other atoms from the molecules are assumed to be removed as ions by counting the shared electrons with more electronegative atoms. Consider an example of hydrogen chloride molecule. Chlorine is more electronegative than hydrogen. Therefore, the shared pair is counted towards chlorine atom. Chlorine gets one extra electron and acquires a unit negative charge. Hence, oxidation number of chlorine is -1. On the other hand, hydrogen atom without electron has a unit positive charge. Hence, oxidation number of hydrogen in hydrogen chloride is +1. General rules for assigning oxidation number to an atom. Rule first. The oxidation number of the element in the free or elementary state is always 0, irrespective of its allotropic form. Rule second. The oxidation number of the element in monoatomic ion is equal to the charge on the ion. Rule third. The oxidation number of fluorine is always -1 in all its compounds. Rule fourth. Hydrogen is assigned oxidation number +1 in all its compounds except in metal hydrides. In metal hydrides, the oxidation number of hydrogen is -1. Rule fifth. Oxygen is assigned oxidation number -2 in most of its compounds. Rule sixth. In polyatomic ion, the sum of oxidation numbers of all its atoms is equal to the charge on the ion. Rule 7th. In binary compounds of metal and non-metal, the metal atom has positive oxidation number, while the non-metal atom has negative oxidation number. Rule 8th. In binary compounds of non-metals, the more electronegative atoms has negative oxidation number, but less electronegative atom has positive oxidation number. Oxidation and reduction in terms of oxidation number. Oxidation is defined as a chemical process in which oxidation number of the element increases. Reduction is defined as the chemical process in which oxidation number of the element decreases. Consider the reaction between hydrogen sulfide and bromine to give hydrogen bromide and sulfur. The oxidation number of bromine decreases from 0 to -1, thus it is reduced. The oxidation number of S increases from -2 to 0, hence H2S is oxidized. Oxidizing agent is a substance which undergoes decrease in the oxidation number of one or more of its elements. Reducing agent is a substance which undergoes increase in the oxidation number of one or more of its elements. In this example, H2S is a reducing agent while Br2 is oxidizing agent. Types of redox reactions. Combination reactions. Combination reactions occurs when two reactants combine to form one product. A good example is the reaction of magnesium with air. Decomposition reaction. Decomposition reactions occur when one reactant decomposes to form two products. A good example is the reaction of mercury oxide to give elemental mercury and oxygen. Displacement reaction. Displacement reactions occur when one element displaces another element from a compound during a chemical reaction. A good example is the reaction of sodium with water. Disproportionation reaction. The reactions in which the same species gets oxidized and reduced means same species changes to its lower oxidation state and higher oxidation state are known as disproportionation reaction. In this reaction, chlorine is oxidized and reduced at the same time. Balancing by ion-electron method. Step first. Indicate the oxidation number of each atom involved in the reaction. Step second. Divide the main redox equation into two half reactions, oxidation half and reduction half. In each half reaction, balance the atoms which undergo the change in oxidation number. Step third. Add electrons to whichever side is necessary in order to make up for the difference in oxidation number in each half reaction. Step fourth. Balance oxygen atoms by addition of proper number of H2O molecules to the side which is falling short of O atoms in each half reaction. Step fifth. Balance hydrogen atoms by addition of proper number of H plus ions for acidic medium and H2O molecules for basic medium to the side which is falling short of H atoms in each half reaction. Step 6. Equalize the number of electrons lost and gained by multiplying the half reactions with suitable integer and add them to get the final equation. Balancing by oxidation number method. Step first. First of all, ascertain whether the reaction is a redox reaction or not. In a redox reaction, oxidation number of at least one atom will change. Step second. Write the oxidation numbers of the atoms whose oxidation numbers suffer a change and write down the number of units of change. Step third. The ratio of molecules of oxidizer and reducer is equals to the change of oxidation number of reducer and change of oxidation number of the oxidizer is ascertained. If the ratio is not a simple one, make it simple. Step fourth. From the above ratio, the coefficient of the oxidizer and reducer molecules on LHS of the equation is ascertained and from which the coefficient of the product molecules on the RHS of the equation is determined. Example. Let us take an example of balancing the equations. Balance the given equation using oxidation number method. Let's see the solution. Here, the given equation is HNO3 plus H2S gives rise to NO plus S. Step 1. Firstly, we assign the oxidation number of N and S. Step 2. Now multiply the coefficient of HNO3 by 2 and H2S by 3. Step 3. Now we balance O atoms by adding 4H2O to the right side. H atoms are already balanced, hence the balanced equation is 2HNO3 plus 3H2S gives rise to 2NO plus 3S plus 4H2O. Redox reaction and electrode process. A redox reaction in which oxidation and reduction takes place in the same vessel is called direct redox reaction. In such reactions, the transference of electrons from reducing agent to oxidizing agent occurs over a very short distance. For example, if a zinc rod is immersed in copper sulfate solution taken in a beaker, a spontaneous reaction takes place and the following observations are made. Zinc rod starts dissolving and loses its mass gradually. The blue color of CuSO4 solution slowly fades. A reddish-brown precipitate of copper settles down at the bottom of the beaker. The reaction takes place with the evolution of heat. The solution remains electrically neutral. The reaction does not continue indefinitely but stops after some time. Electrochemical cell. An electrochemical cell is a device in which chemical energy is converted into electrical energy. These are also called galvanic cells or voltaic cells. Let us consider the redox reaction between zinc and CuSO4 solution. Zn and CuSO4 solution are taken in separate vessel. Zinc rod is dipped in ZnSO4 solution so that Zn and Zn2+ come in contact at the interface. Copper rod is dipped in CuSO4 solution so as to make the contact between Cu and its oxidized form Cu2+ ions. An arrangement involving contact between the oxidized and reduced form of the substance at the interface is called redox couple. The two metal rods act as electrodes and are connected by the conducting wire through a galvanometer. The two solutions are joined by the inverted U-tube known as salt bridge. The U-tube is filled with aqueous solution of some electrolyte. The electrode at which oxidation takes place is called anode, and that at which reduction takes place is called cathode. In the electrochemical cell, a salt bridge serves two very important functions. It allows the flow of current by completing the circuit. It maintains electrical neutrality. Did you know? The corrosion of metals is a naturally occurring redox reaction. The atom which gains electrons reduces its valency, therefore is reduced and is called the oxidizing agent. The atom which loses electrons increases its oxidation number, therefore is oxidized and is called the reducing agent. The redox reaction in a galvanic cell is a spontaneous reaction. For this reason, galvanic cells are commonly used as batteries. Summary. Let us summarize what we have learned. Oxidation is a process of addition of oxygen or any electronegative radical or removal of hydrogen or any electropositive radical. Reduction is a process of addition of hydrogen or any electropositive radical or removal of oxygen or any electronegative radical. The species which undergo the loss of electrons during the reactions are called reducing agents. The species which undergo gain of electrons during the reactions are called oxidizing agent. During the redox reaction, there is transference of electrons from the reducing agent to the oxidizing agent. Oxidation number is the residual charge which its atom has when all other atoms from the molecules are assumed to be removed as ions by counting the shared electrons with more electronegative atom. Decomposition reactions occur when one reactant decomposes to form two products. Displacement reactions occur when one element displaces another element from a compound during a chemical reaction. An electrochemical cell is a device in which chemical energy is converted into electrical energy.